Hi everyone, and welcome to today's webinar, How to Use a NoSQL Database for Operational Query, Full Text Search, and Analytics. Here are a few guidelines before we get started. All attendees are on mute, but you can submit any questions through the Q&A box and we'll try to address them at the end of the hour. If you're having audio issues, please make sure you're using a Chrome browser and try refreshing your page. The webinar recording will be sent to you in a follow-up email, and you can download the slides at any time in the resource folder. With that, I'd like to introduce our speaker for today, Ben Lee, Principal Product Manager here at Couchbase. Ben, over to you. Sorry, we're just having the screen share set up.
Hey, good morning, everyone. My name is Ben Lee. I am the product manager for Couchbase Query and GSI. Basically, anything around query, that's me. So for today's webinar, I'm going to be focusing on the topics of how to use NoSQL database for operational query, full text search, and analytics. But everything is under the kind of the subtitle of SQL for JSON. So before I get into the topic, let's look back a bit briefly on how the NoSQL database came to be. Today, customers spend more time interacting than transacting. We know that because some of our customers are telling us that it can now take up to 3,000 interactions to drive a single transaction. Clicking on a link or liking a tweet or starting a game, entering a search term, completing a form, all of that are basically interaction only when you making an online payment that is a transaction. So for travel and hospitality industry, the interaction may include searching for a flight or hotel room, comparing deals. Interaction include browsing the product catalog, personalizing your recommendation, giving your rewards. The transaction is completing your purchase and paying. For the digital media, interaction may include permission and access control, browsing content, personalizing content. The transaction here is streaming the video. For financial services, interaction may include searching for your transaction, protecting against fraud, delivering credit reports, or cross-selling mortgage, insurance, etc. The transaction here is moving money from A to B. So with the massive amount of interaction, it's not limited to only to the customer-related kind of app, e-commerce style interaction, but also across the entire spectrum of enterprise applications. And at each level, this interaction to transaction ratio occur at different frequency, ranging, for example, from 1,000 to 1 for customer apps, and up to 1,000,000 to 1 for IoT solutions that serve up machine-generated information in real time. The technology that is used to serve up these services are not the traditional RDBMS backend. So why is the traditional RDBMS is not ready for the digital transformation? For traditional RDBMS, the enterprise application market dominated by high value, low volume, and complex transactions like ledgers and banking, airline tickets. The technology here is often based on legacy, monolithic infrastructure, and often based on relational database, designed for transactional purpose, then coupled with a dedicated platform for analytic needs. In the new kind of digital world, the enterprise applications are overwhelmed by metadata and pre-transaction data, supporting interaction that are in the scale of 1,000 or more to one transaction. This microservices architecture support web, mobile, IoT at a much greater scale with performance to match. Traditional RDBMS is collapsing under this new flood of data, And this is where NoSQL databases such as Couchbase comes into the picture. So let's talk about NoSQL database. I mean, while RDBMS were designed to predominantly focus on managing system of record, NoSQL database, because of its scalability and its initial goal to handle modern web interaction, grew very quickly in the past 10 years. New database technologies start to appear with goals such as schema-free, replication, fully distributed, and kind of eventual consistency. These databases try to address new challenges, such as the need for high throughput and low latency, such as those that are delivered by document store and key value database, and also the graph database to harness the power of data connection for social networking. Today, there are around 28 different categories covering over 255 different database systems. But for today's discussion, I will focus mainly on the document store database category, which cover a long list of databases such as Elastic, MongoDB, DocumentDB, Couchbase server included in them. And these document store databases or JSON databases are the main focus of the discussion, i.e. SQL for JSON. So when we talk about document database in today's enterprise application, we need to decide how to represent the business application as a document model. Let's take a simple sales order kind of system. You have customer order and order lines and sales rep object. The document model at its simplest form is a schema-free structure. By that I mean documents do not have to have the exact same field from each other. It also supports hierarchical data, allowing the document to contain subdocuments and, of course, arrays. So when organizations want to start using document database, they sometimes rely on data modeling tools like Irwin, etc., to help with transformation of the traditional relational schema to the document model. And one approach is simply to denormalize the relational schema to arrive at a consolidated view of the object. So if we were to follow that denormalization method, it is simple to see that you can bring all of the orders and order lines into the customer document. Of course, you can also do the reverse and stay at the order and bring the parent customer object in. And this approach works to a certain extent. But what if you need to also query orders by the sales rep? Then the full denormalization approach will end up replicating the order information inside the sales rep document. So clearly, this is not an ideal, nor can it work in all cases. So let's review how we can solve this problem in the next few slides. Now let's consider another data model for the activity management application, which is used in many of the popular CRM systems today. Let's look at the data model characteristic here. Here, the main object that it is tracking is activity. Activity can be of type appointment, task, each with its own set of attributes. Activity has its own kind of contacts. Task has associated to-do list. Activity are owned by account and user. Activity and account and territory are associated with team of internal user. Contacts are also directly associated to an account as well as the activity. And accounts are assigned to territory, and both user and territory support hierarchy. These are the typical kind of relational model kind of design today. To follow the denormalization approach into a single document, you will need to include all of the related activity objects in the activity document, and that is a real challenge. For instance, how would you store the contact information in the activity when contacts are directly associated to activity as well as indirectly via the contact, via the account object? You mean the same problem with user. A user is associated to an activity as an owner, but the user also associated to activity as participant. So it would be impossible for simple denormalization approach, which is the core requirement for most document databases, to work with a real enterprise model like this. It seems obvious, but the only way is to retain some of the normalized aspects of this data model, i.e. denormalize where it makes sense and keep the object normalized where they need to. But that means the need to join documents. For NoSQL databases that do not support the ability to join documents or only provide limited support for join, such as MongoDB and DocumentDB, it would be very difficult for customers to consider the NoSQL solution for their enterprise application. But with Couchbase NoSQL, you can decide. You can use a fully denormalized model if your application can be adapted to that, or use a hybrid model where certain objects can remain normalized. Then you can use Couchbase NiCO ANSI join to query the related information. In terms of how you can migrate your data model from relational to JSON document model, you will have to make the decision based on your need. I often recommend looking at the data access pattern and use that as the basis for your decision. However, the actual process can be boiled down to 3 different kind of strategies. You bring your relational table directly into a JSON document. Of course, you can also bring the child object at the same time. The second strategy is to denormalize the associate parent or master detail in with the object. For instance, you don't just bring the account table over, but also include account owner information across as well. This is similar to relational model, and is called the use of the foreign key. But here you want to include more detail on the foreign key object so that you can avoid an additional join when you need to see the account and the owner name at the same time. The third strategy is adding detail object to the parent object as an array. For instance, you add the account team members, which is our users, as an array to the account object. So here is the view of the JSON document. You can see that the document model here, it maintains the object relationship and embed where necessary. The activity object combines both activity type with each its own set of attributes, i.e. the to-do list for task and contact for appointment and others. This is much more efficient than the relational model because the activity document for appointment will now only have the fields that are specific to the type of activity. Activity context and activity user are represented as array elements. This is the third strategy on the transforming your relational to JSON model that I talked in the previous slide. And finally, account and user territory are maintained as separate objects. Again, this is the hybrid model where these objects are still kept normalized, similar to your relational model. This document model means that you only need to query the activity object for most of your query needs. But if you need to look up more detail about your activity owner, user, etc., such as the experience or the skill set of the user, then you will need to use the join. Similarly, you can join to account for more specific detail about the account, such as their industry, or another join to territory if you need the territory detail. So let's compare how other databases support JSON documents. Let's first look at Oracle. With Oracle, JSON is built on top of the Oracle RDBMS. It's basically JSON is built on top of the Oracle RDBMS construct, and JSON is supported as a data type. So you create a table as a standard Oracle table and have an activity column as a JSON type. You can see that the insert is also fairly straightforward, as you can simply provide a complete JSON document for the activity document column. But it starts to get a little bit tricky when you want to query the JSON document. Oracle provides special JSON functions that allow you to extract the individual fields of the JSON document. You can do this at the field level or at the table level with JSON table function to extract convert multiple fields at the same time. The last query is an example of how Oracle SQL used JSON table function to extract the participant element, which is an array in the activity JSON document. Now let's look at how Couchbase NoSQL works with JSON documents. First, you do not need to create a table. Couchbase starts with a bucket, which is similar to a database. Similar document model supports flexible schema. You can simply insert your document directly into the bucket. So create table is not required with Couchbase. When you insert the document into Couchbase bucket, the insert command takes a key and value fields. You can provide specific string for the key, and a value is simply the JSON document. Notice the syntax is very similar to standard SQL. There is only one additional type field that we use here, and that is the type column. It is a common practice to use the type field to denote the type of object. In this case, the value is activity. The same bucket is used to store other type of documents such as account and user. And retrieving the JSON document is by using the standard SQL select. Here, for those who are familiar with SQL, this is exactly the same ANSI SQL select syntax. So let's examine side by side the two JSON implementations. The first column represents the standard RDBMS SQL, which could be Oracle SQL Server, MySQL, DB2, etc. The second is the Oracle implementation of JSON, and the right is the Couchbase NoSQL for JSON. This slide really shows how Couchbase has focused on adopting an open standard when it comes to querying its JSON database. This allows organizations to benefit from the high throughput, low latency, and elastically scalable of Couchbase NoSQL, and at the same time allows developers to leverage their familiarity of SQL. There's very little new syntax that you need to learn with Couchbase NoSQL. Actually, of all this JSON support in today's NoSQL, the Oracle way of supporting JSON looks rather complicated. Let's also examine how other NoSQL databases handle data access. On the left-hand side is MongoDB approach. It uses a proprietary API to support all of the standard DML needs. Mongo API is a procedural approach versus NoSQL, which is a declarative. The important aspect about Mongo procedural approach is that it is a proprietary API and would require some specific training comparing to an open standard like SQL, where most application developers are familiar with. The syntax for simple query is fairly easy, but as the proprietary API go, it can get complicated very quickly, as I will show you in some example later. To the right is the PostgreSQL. This is very similar to Oracle approach, where the JSON model support is not native to the database implementation, but a data type. As such, it would need special function or syntax, in this case, to retrieve the data. That's a general expectation that document databases are very fast at retrieving using the key value approach. But would the database still perform if we use SQL to access the underlying document? On this slide, I'm showing you a report published by Altaros, the company that focuses on helping companies to shift from their legacy IT system to the future. They have worked with all the big JSON database companies, such as MongoDB, Redis Lab, and Cassandra. As you can see from this YCSB benchmark, the YCSB kind of workload E, which basically a query that involves range and range scan and sorting, show the performance of three databases: Couchbase, MongoDB, and DataStax Cassandra SQL. The table on the left shows the actual command used for the task. Couchbase NoSQL use a range scan, and sorting, and limit for pagination. Same thing applies to MongoDB. There's a way to find the document with a special syntax for sorting and limiting the result. Cassandra SQL, again, which is very similar to SQL. I mean, the tests will run on 3 different cluster configuration hardware, and size of the data set kind of scale in accordance with the cluster size. 50 million order on a 4-node cluster, and then 125 million order on a 10-node cluster. And last one is actually 250 million orders on a 20-node cluster. You can see that basically Couchbase NiCO query latency response time is very similar to Mongo, and both are much faster than DataStax. But NiCO throughput is not as good as Mongo. 10K versus 14K for Mongo with the small cluster configuration. But when this is scaled up to the 10 node, you can see, while the latency remains pretty much the same for Couchbase and Mongo, the throughput changes significantly between Couchbase and Mongo. The difference is even clearer when we look at the 20-node configuration. What this tells us is how linearly scalable Couchbase cluster can be. The more nodes you have, the higher throughput you get, while there is no effect on latency. And this is why Couchbase is used in many of the mission-critical applications, such as airline booking, where it can deliver massive throughput to handle user interaction. So take a look at Couchbase NiCO work with something a little bit more complex than a single object query. Say we need to get a list of all customers and their contacts who might be at the meeting that a user will be attending. For the standard RDBMS, the query would have to join activity to account, and then you join account to contact, and then you join from activity to participant so that you get all the activity where, in this case, user 73 participated in. For Couchbase, the JSON model still requires a join from activity to account to get all the contacts. Then use unnest to flatten all of the contacts for projection. Participants are already embedded as an array in the activity object, so we use the array predicate to filter out the activity for user 73. You can see the language is very similar to standard SQL. I mean, it introduces the concept unnest to flatten an array of contacts on the account object, and also the special array predicate construct to filter directly on the participant array. You can see that NiCO is not that different from standard SQL. But too many NoSQL databases in the market today, the idea of join is not something that they want to support. The primary reason that was given is that join will be slow. Well, I think there is some truth in that. So let's see how Couchbase NiCO join and aggregation perform against other NoSQL in the performance benchmark. On this slide, I'm showing you a report again published by Alteros using the YCSB test that involve aggregation and join to generate the monthly sales by zip code. The table on the left shows the actual command used in the test. The Couchbase NiCO would join the customer to order dataset, then a group by month and zip code, then an aggregation on the sales price. A MongoDB API involves a call to get the list of zip code, then pass the zip code list into another Mongo aggregation API to aggregate the sales price by month and zip code. And the last one is DataStax SQL. The SQL query directly on the customer order join document with the standard SQL group by an aggregation, which is very similar to standard SQL. Notice that it queries on the denormalized document as it does not support the join. Again, the test was run on 3 different cluster configurations, and the data set size scale in accordance to the cluster configuration. 10 million customer and 10 million order on a 4-node cluster, 25 million customer and 25 million order on a 10-node cluster, and then we're up with a 50 million customer on a 50 million order on a 20-node cluster. you can see that NiCO outperformed the other databases by a very large margin. Couchbase was able to execute around 1,180 queries per second on a 4-node cluster, an average request latency of about 500 milliseconds. And that's using 700 client threads, by the way. The 10-node cluster performed at 1,100 queries per second with a latency around 650 milliseconds. So as you can see, Couchbase NiCO is a SQL-like language. It supports fast document key lookup and range, scan, and sort when you have a highly denormalized model that you do not need any join. And it can also support high throughput and fast response time for join aggregation where the application document model requires a more normalized approach. But Couchbase NiCO does not stop there. Its NiCO language capability extends to cover many advanced ANSI SQL standards, such as CTE. This is the common table expression, a technique that allows developers to isolate SQL statements into temporary named result set that can be referenced as a source table in the context of a large query. It offers the advantages of readability and ease of maintenance of complex query without compromising performance. It also supports analytical window function, and where this is actually the analytical aspect come in. It can be used to answer common but complex business query with minimal lines of code and optimized performance. The use case here is a query to show how the sales-related tasks have changed month over month. You can also see how NiCO support for advanced ANSI SQL is almost identical to that of a SQL implementation of the feature, which is what I have on the left there. So the next area about NiCO that I want to talk about here is how Couchbase query service works. It has been designed as part of the standard Couchbase scalable services architecture, where you can deploy as many query services on as many nodes that you have in your cluster. The job of a query service is to evaluate the query state and using the query optimizer to determine the execution path and choose the most efficient and generate the query execution plan. The query services, in turn, interact with another similarly scalable index service to provide faster data access. The index service works the same way as any other standard database index, although the Couchbase index service can be configured to use the memory-optimized index model or our Plasma storage engine, where the index service can optimize its memory usage with the fast secondary SSD storage. The data service is the most fundamental of all Couchbase services, providing access to data in memory and on disk, provide a highly available and dynamically configurable distributed data storage with persistent and replication services. In addition to all this is the search service that provides extensive capability for natural language querying, language-aware searching, scoring of results according to relevancy, and fast indexes which support a wide range of possible text searches. Couchbase full text search service is a standalone service and has its own API application development. However, it is also integrated to the query service, allowing NiCO query to leverage the search services directly. Here's an example on how Couchbase NiCO for JSON leveraged full text search. The capability is accessible by the NiCO search function. So let's consider a simple query search use case. I need to identify the customer account and their related contact where a particular topic has been discussed. The search criteria may include one or many of the following information: the meeting title, the date of the meeting, customer contact details, sales team members, etc. To do this with standard RDBMS, we could write a SQL with a number of wildcard searches. For example, where meeting title contain the text intelligence and the customer name like James, and also a join to search for the subquery. A lot of wildcards are used, but that is what will be required in standard SQL. Using NiCO search, we can leverage the full text search capability, passing in what we need to search for. Here, the search leverages an FDS index that allows a fast search on all of the relevant fields in the activity document, including searching for the array components such as the activity participants and the contact array on the activity. Couchbase full text search has been designed to handle this type of complex search very efficiently. The benefit here is not only with fast query response time, but also the fact that a single FDS index can be used to support a wide range of query patterns. Furthermore, developers only need to use a single approach, i.e. the SDK, to leverage both NiCO and full text search. So to wrap this up, Couchbase delivers a NoSQL database built on a foundation of developer agility, performance at scale, and manageability with security and high availability at every layer. So how does it look in some of our biggest accounts? LinkedIn provides a single view for 630 million plus accounts. All in-memory storage in LinkedIn data center is done by Couchbase. Tesco, which is based in UK, store and update product data for 10 million plus items, scales to support 35,000 requests per second, as well as Black Friday traffic. Amadeus, a travel platform, supports 8 million ops per second under 2.5 millisecond response time, and they are a heavy user of NiCO. Comcast provides a single view to their 100,000 internal users, accessing 210 million documents from phone. United Airlines uses a cruise scheduling application, provides support to 41,000 people using Couchbase to make sure you arrive safely and services millions of travelers. So the next part here, I want to do a quick demo on the power of NiCO and the relational and JSON document itself. So to do this demo, the goal is that I'm going to try to show you how basically we can pull data from relational database and using NiCO to transform the data and insert that directly into a Couchbase bucket. For that, what I've got here is actually I've got an Oracle database running on a VM on my machine. It has all of the table, as I mentioned to you in that relational model earlier, with account team, activity, and all of that. And then what I then use here is actually I have another Couchbase instance running on the same network. Here I can show you that I can query directly on the Oracle database. If you look at the query here, all of this is actually part of the NiCO query. Only the inner part here is actually the query that actually for the Oracle database. So you can see that a single query pulled data directly using the curl construct and then transform the data into a table, as in the first strategy I mentioned. And I pull all of that into a script. So the first step here is actually pulling the data over for the user, for the user table. Then the next query here is pulling the data over for the account, object. And then I leverage basically the third strategy whereby I pull in all of the contact and merge that into account, because a contact is part of the account object. Likewise, I'm doing another call to pull all of the data for the account user as basically the account team. And these are all the script that I can kind of run right now. I mean, right on my server, I have an empty bucket here called CRM staging. And the query I have here is what I just showed you guys. I can execute that, and you can see that it actually starts going through very quickly here. You can see the basically the activity on the buckets. Yeah. So pulling data directly from Oracle and write it to the Couchbase bucket. It's still executing on step 8 here. Because this is a live demo, so I kind of reduced the data set around to about maybe 10,000 a row or so that we can finish it in time. As you can see, it has completed moving all the data over. Now I can look at the CRM staging document bucket, and I can see the data that is being pulled into in here. So here, in this case, is an account. So if you look at account, you can see that in the example that I show you, like using the third strategy whereby I create the account object document first, and then I bring in the array of contacts into the account object, including the array of user as team for the account. And once it's in Couchbase, then I can start querying it just like anything else. In this case, I'm using basically select. Basically you can see that I getting some of the data out. You can build it in the as a table view or a JSON document. And for example, the other one that I was showing you earlier is actually the CTE query on that same data set, showing you the month-over-month change of activity on this data set. And lastly, this query also kind of try to show the different, how much data I have brought in. So like that, it's all about 19 territory, 114 user, 500 account, and 1,000 activity. And here's an example I mentioned earlier whereby the NoSQL query actually leveraged full text search in the query in the query, and there you are. I mean, basically you can see how. I know it's a small data set, but you can see that it's designed. The query full text search is designed to actually return this kind of search very, very, very quickly. And let's see what I have here. So that's pretty much wrap up my demo here. Let me go back to slide. So the demo basically is trying to highlight a couple of things. Basically, the power of NoSQL, which is everything in blue here, and how it managed to bring data from another database. In this case, I leveraged the Oracle REST data service, and the ability to actually transform that data either into a single document or and merge that into as array on another document, or perform using the NoSQL query language itself. So that's pretty much like the end of my presentation. If you have any questions, now maybe we can actually go through that.
All right, thanks, Ben. The first question is, How does Couchbase nickel join work comparing to other NoSQL vendors such as Mongo or Cosmos DB?
All right. So, as I mentioned earlier, Couchbase nickel approach to join is that it support all kind of ANSI join standard. By that I mean not only the inner join, level the join, but they also support hash join and all of that the kind of join that you're familiar with. In fact, it's even with 6.5 we can even join with subquery. But other NoSQL database, particular Mongo has a concept called lookup. Basically, it actually gives you a left-outed join kind of approach. It's worked pretty well from that context. But notice that MongoDB lookup only works if your data is actually not sharded, which is pretty limited because if you have a lot of data, you do need for it to be distributed across many nodes. So the MongoDB approach to lookup is kind of okay, but providing you have very small data set. The other one I'm thinking of, perhaps, in fact, not many other document databases support join. Whether you're looking at even Cosmos DB, which have a very similar kind of SQL language to query data, it doesn't support join. Elastic and all of these databases are focusing on the fast query, and they all kind of avoiding the join altogether. And in a way, I think that's something unique about Couchbase because of the architecture that we design on not only the query but the indexing service, how we actually tightly couple the whole services that allow us to leverage the join to work kind of fairly efficiently, as I show you in the Atlas report there.
All right, next question is, beyond semantics, what is the difference between a NoSQL database's implementation of SQL and a traditional RDBMS's, like, say, Oracle's?
I think the big difference that if you look at how NoSQL database generally have been designed, especially Couchbase, the architecture of how it scale out, horizontally scale out. And, the way that Couchbase is actually kind of designed is the concept called multi-dimensional scaling. So not only that you can actually have all of these services running on one big box, which is perhaps, if you look at from the Oracle perspective and relational database, that's how it works. Or to turn it around, you actually can have smaller nodes, but you have multiple nodes, therefore allowing you to scale out horizontally using perhaps more of a kind of a commodity kind of hardware. And in fact, that's a good question. That's why the popularity of NoSQL has been what it is in the last 10 years, because we all know that with Oracle, it can do everything that you want, but you would need a much bigger hardware configuration in order to support that.
All right. Next question is, I heard about cost-based optimization. Can you talk a little bit about that?
So yeah, I wasn't able to include the cost-based optimization on this webinar because it's actually something new that we delivering as a developer preview in Couchbase 6.5. And so basically, cost-based optimization is an optimization technique that for those of you who have worked with relational database in the past would be aware. In fact, most relational database uses cost-based optimization. Is an area that has been written about for the last 30 years, and you have. And even today, there's still new white paper coming out from Stanford of how to do cost-based optimization. And Couchbase optimization is unique in a way because this is the first time that anyone tried to come up with a cost-based optimization on a schemaless kind of database. because cost-based optimization, you have to rely on statistics, and statistics is calculated on the structure of your table, of your columns. But here, with NoSQL, with document database, every document can be different from one another. So that is something that unique to Couchbase in the way that we have implemented cost-based optimization. In the near future, we hope that cost-based optimization is going to be the default optimization method for our query, because at the end of the day, from a query optimization perspective, the query planner simply have to look for the cheapest plan to execute and choose the particular path. And that's something that we basically we work towards in perhaps after this developers preview release of 6.5.
All right. Next question is, does Couchbase support transactions as well? If yes, is there a performance decrease with transactions?
Right, yes. In 6.5, we bring out a kind of support for transaction. And transaction mean different things to different applications. And that's different level of what we call isolation level that you can configure. And it depends on the different needs, because there are certain levels that you can set to ensure that the transaction is actually all completed, in all the different nodes, or only on the master, or only in kind of at memory. So each of those has a different kind of cost related to that. To answer your question is that yes, there would be some additional cost, but you can make a decision of how far you want to ensure the transaction are committed to all the different nodes. Bearing in mind, as I mentioned to you, in terms of data services, all the data are just distributed across different nodes, and so and some are in memory, some are not. So you can decide, but there are different settings there that allow you to sort of configure to best fit your need. There is a small cost to that, so that's why it is not a default setting that we would use. That's what, for example, in RDBMS, that would be default, but with NoSQL, it is something that optional, and you can configure to the way that you want to use it.
Okay. How can you store and query XML data in Couchbase?
So basically, that's not something that we, in terms of storing, you can store any kind of data, but querying, we don't have a kind of a direct kind of a way to do that, unless we kind of we're looking for some kind of additional library. As I mentioned to you, with the list of 28 different category of database of over 255 databases out there, there are XML database. It's just not something that that kind of we're doing. Although if I go to our forum, I'm pretty sure that people would try to use it, and perhaps use some other external library to kind of retrieve the data.
Do you provide guidelines on setting up a structure under NoSQL that is optimal for performance, and would the structure design hold up when scaling up by any order of magnitude?
So I think that's kind of something that is difficult to measure. Basically, if you look at the document kind of design model, as I mentioned in the webinar, for organization who wants to kind of able to embed all of the kind of the data into a single document design, then that would be the best performance. I mean, that's no two way about it. And you can look at the our performance benchmark that wasn't that performed by us. It was performed by a third-party company. You can see that it performed extremely well and how it scale as you actually increase the data and also increase the hardware configuration. But as you basically decided to go to a more normalized, a hybrid model, as I think I mentioned, then there will be some join. And join, there are costs. It's just, I mean, the NoSQL database vendor people out there do know that, and there's a cost to that, and you have to balance how you can leverage that. And the reason why we can deal with the join, the cost of the join, is because of the way that we design our index services, very tightly coupled with our query service, and a lot of the join and all the complex aggregation are basically pushed down to the query, pushed down to the index service level. So that's something that we can leverage. But at the end of the day, I think it's basically providing that we provide all different kind of join to leverage to give you the performance, because it's not only about the standard join but also hash join that would actually be extremely fast. But like I said, it really depends on your need. No document, no join would mean that your performance is very scalable. With join, you're going to have to there would some cost in terms of ensuring that your index services are configured correctly.
How do updates get processed? For example, if I change a user's phone number, do all the documents with that user need to get updated? What is the performance related to that?
So the way, of course, if you update the information, from a database perspective, all of that update will happen to all the underlying data. But with the way that our database works, is because it allows you to effectively the update to what we use the term eventually consistent. So if you rely on that approach, then yes, some of your query may not see that update immediately. But eventually all of the update will be seen by all the clients. If you have the need to actually see the actual update immediately, then you can actually configure in your API call to say that you want it to see the update immediately, and thereby the query would be perhaps it will have to wait until all the data get updated before you return the result. This is no different from RDBMS as well, in terms of readability, release logs, and on all the isolation level that come with database. We provide all the options for your need. Like I mentioned to you, basically NoSQL database is great for interaction, and a lot of these not necessarily, you don't necessarily have to wait for the latest information, which is great. But then, if you want to use for transaction purposes, then yes, you do have to ensure that you read the data in a particular mode in order to ensure that you get the consistent of the data. All that is supported in the transaction support that we have in 6.5.
Is there a data dictionary in Couchbase that can show any/all objects on demand? That's something we're working toward. Today, as we showed earlier, that we have basically on the right-hand side of the Couchbase, the query workbench, we have a way for you to browse the schema. And what that means is that on the back, we have a process running that doing an infer schema, and effectively kind of try to do similar to RDBMS describe, and give you the schema on the right. But that's the solution that we have today. In the longer term, we plan to, basically this is something that we're also working on. The concept of collection and all that, we'll kind of find a way to actually kind of instantiate all that in physical form so that you can actually query. Okay, does NiQL allow for multidimensional arrays, i.e. array nested within an array? Absolutely. If you look at the NiQL construct, or if you look at document database in general, one of the key differences between this kind of database compared to relational is an array. And NiQL has a very, very rich set of array operations that allow you to handle multi kind of dimensional array. If you look at this and if you
think about how relational database does it. Oracle has a concept of list aggregation. It's the same thing. And allow you to manipulate array, and that's kind of a very kind of complex, but I don't think it actually supports multi-dimensional level. Whereas the array function that we have in NICL, and I recommend you go to our Couchbase documentation, that the different kind of function we provide for array operation is really kind of quite rich, because like I say, not only the operating on the array, but you can actually perform. This is something that I always find really great about Couchbase and NICL. You can actually using array join. So think about it. Basically, not only the joining at the document level, but you joining at the array element level, which is something that's a very powerful technique if your model requires that kind of level.
All right, great. Looks like those are all the questions for today, and we are going to give you 4 minutes back today. So thank you everybody for joining this webinar, and thank you for all your great questions. As a reminder, you can also download the slides in the green folder icon below. Please also take a few minutes to answer the survey that will pop up on your screen so we can make our webinars better for you. Thanks again and have a great day.
Thank you, everyone.